Hi friends, welcome back. Today I'm planning to do a question from mathematics. This is quite an interesting question. That's why I thought of doing this one. I usually do questions from mechanical engineering, but this question seems to be pretty good. That's why I'm doing, and I feel this particular question you mostly this is not found under any of the conventional topics that you may study for exams like GATE. So, without much ado, let's get started solving this problem. Now, they're actually telling us there is a spatial curve, there is some spatial curve, some random spatial curve. If you can say this is the 3D plane, there is some curve like this in 3D. So they are asking us to calculate what is the length of the curve. So question makes sense. I hope it is clear. Now let's start doing it. Before going to solve this problem, let me drive home a few concepts. Now just forget about 3D and just focus on a 2D plane like this. You have your x-axis here and you have your y-axis here. Now let's say I'm talking about an arbitrary curve of this shape. Let's say this point is my x1 and this point, I will keep that as subscript so that let's say this is my x1 and this is my x2, these two extremes. X is for the coordinate actually, so x is the coordinate. Okay, I will write x here. Now our objective or what we are trying to do is we want to figure out what is the length of this particular curve in this domain. To do that, what we'll do is we'll consider a small strip here. Let's say this small strip we can magnify and have a look at it. Let's take it here. Now this is that small portion. Actually this small portion I'm taking out and I'm drawing it. I'm exaggerating it. So let's say this is that portion. Let's say this is distance dy, the small change in your y coordinate, and let's say this is the small change in your x coordinate. Now the length of this particular curve can be approximated. This is curved, but since we are saying this change in x is so small and change in y is so small, the curve length at that portion can be approximated using Pythagoras theorem. Let's say this ds is the length of the curve in that small area, in that small portion, then ds can be written as ds square is equal to dx square plus dy square. Makes sense? So now we have effectively computed what is the curve length in this particular portion. This is the curve length. We have effectively computed it. Now, having computed that, now let's go ahead and do what will be the curve length from x1 to x2. How to calculate it? Let's say s is the total curve length, then it is integral x1 to x2 ds, where ds is root of dx square plus dy square. Make sense? Okay. Now let's extend this. Let's extend those concepts to. Consider that there is a 3D curve as shown in this figure. Now, as shown here, this is a 3D curve, let's say. Now only this portion of the curve is isolated here and it is shown here. So this is that portion of the curve. I have shown it in using a different color. Now around this portion of the curve, we can actually consider it as a diagonal of a cube. We can consider it as a diagonal of the cube of where the cube dimensions are dx, dy and dz. Now what does this imply is that if we want to compute the arc length, then arc length can be shown like this. ds is equal to root of dx square plus dy square plus dz square. Clear? Now coming to our problem, so see or appreciate yourself that this in 2D it was just these two terms alone. We extended it to 3D, there is another term coming. Now for this particular problem, if you look at dx can x, y and z are given in terms of t. So dx can be written like this, dy can be written like this, dz can be written like this, simple algebra. Then ds can be brought down to here, can be written like this. I missed out something here. Sorry. Actually, there should be an dt here. There should have been a dt here. Okay. Makes sense? Now let that be here. Okay, that's good. Now computing the total curve length from 0 to pi by 2 ds will be 0 to pi by 2 root of 1 plus 2 by pi whole square dt, which will be simply pi by 2 times root of 2 by pi whole square, which is 1.86. So this is the answer. I hope you understood the underlying concepts behind this question. Thanks for watching.